A ball is dropped from the roof of a building. Points A, B, C, and D in the diagram below represent the position of the ball as it falls. At which position will the ball have the greatest kinetic energy? Well, that's where it's moving the fastest. And so up here, where you started, it's not moving much at all. And as you drop it, it's starting to convert that potential energy into kinetic energy. So it's getting faster and faster and faster. The farther it falls, the less potential energy it has, and then it's transformed to more and more kinetic energy. And then when it bounces off the ground, it comes back up, but it really doesn't bounce as high as it, when you initially dropped it, because some of that energy is lost when it hits the ground through heat. When it smacks the ground actually does heat up a little bit. If you've ever taken a nail with a hammer and kept hitting it over and over again really, really fast, the nail will heat up whenever it impacts. And so some of that energy is lost as heat when it hits the ground. And that's why like a super ball will never, if you drop it, will never bounce higher than the position that you drop it from. Now, if you take your hand and push it a little bit and throw it towards the floor, you can get it to bounce higher. But if you just strictly let go of the super ball, it will never bounce higher than the original position. So right here at C is where it's going to be traveling the fastest, because some of that energy will be lost when it hits, and when it bounces back up, it won't be moving as fast when it converts to kinetic energy.